Good morning. Today we're going to talk about Unit 1, Lesson 6, solving problems involving polynomials. So today we're going to put together everything we've learned so far about polynomials and applying it to word problems. So let's get started. Polynomial equations can be used to model word problems. The word problems might ask you to identify certain things, and they are usually key features of a polynomial. In particular, we've looked at quadratics in the past, and they might ask you about certain things. So maximums could represent maximum height. If it's related to money, it could be revenue or profit. Could be the maximum speed. Okay, I'm just going to put etc. So lots of things when they're talking about a maximum. And when we're thinking about a maximum on a graph, when we're talking about a quadratic, the maximum is our vertex, right? So there's lots of ways we know how to find our vertex. So we have to identify what the word problem is asking us to find and then determine how we find that within a graph or within an equation. Zeros, when they're put in word problems, they could represent when an object is going to hit the ground. Or water. And we'll look at some other examples of what those zeros could represent. So finding y value, sub value into x variable and simplify to determine the y variable. So they might give you some information that you can just substitute in and then find the other variable. If we need to find the x value though, we're going to sub our value into our y value, into our y variable, and then rearrange the equation to be equal to 0. And then we would factor to determine the x-intercepts and rule out any unrealistic intercepts. So we are going to sub-value into y. And we're going to rearrange so that the equation is equal to 0. We factor to determine those x-intercepts and then rule out any unrealistic x-intercepts. So let's take a look at an example here. So the yearly profit in thousands of dollars for the sale of n thousand tins of tennis balls can be modeled by the function p of n equals negative 0.1 n to the power of 3 plus 1.86 n squared plus 8n. So it says determine the yearly profit on the sale of 15,000 tins of tennis balls. So 15,000 tins represents our n. So we're going to sub n equals 15 into the equation. And solve for P of n. Remember, it says that n is represented in thousands of tins. So n is thousands of tins of tennis balls. So when they tell us 15,000 were sold, we can just substitute in 15 because we know that that represents 15,000 in our equation. So we're going to sub in 15 into the equation. Anywhere we see n. And when we do, we get 15 to the power of 3 times negative 0.1 is going to be a negative 337.5 plus 0.86 times 15. Sorry, that 15 should be squared. So 15 squared times 1.86 is going to be 418.5 plus 8 times 15, which is 120. So we simplify all that and we should get 201. So we found that when we substitute in 15,000 for the number of tins sold, we get 201 for our profit. Remember that our profit is also in thousands of dollars. So whenever we have a word problem, we need to then end it with our therefore statement. So therefore, the profit when 15,000 tins are sold is $201,000. Okay, the next question is saying, for what number of tennis balls is the profit a maximum? So the next question says, for what number of tennis balls is the profit a maximum? So it's asking for what number. So the number of tennis ball tins is represented by n. So we need to find n so that profit is a maximum. So whenever we've worked with maximums in previous math classes, like we're talking about quadratics, in order to get to our maximum, we need to first find our zeros. So we'll say need to find zeros. Okay, and then we'll work towards our maximum from there. So remember our original equation Okay, so there are the values when we plug in different numbers for our n. So we can see that at 11,000 tins, the profit is going to be 179,960. At 12, it's continuing to go up. At 13, it's continuing to go up. 14, it's continuing to go up. So we can see that the profit is continuing to increase. If this was 11, for example, let's say 11 is right about here, right? We're here, and the profit's continuing to go up, continuing to go up. We have to figure out when's it going to go down. So we'll try one more. If we sub in 15 for my n value, you get 201. So you can see that at 14, it was at 202.16. And then it went down from there. So that means this must be, oh gosh, this must be our maximum at P14. So 14,000 tins, this must be our max. So if we thought about the graph, well, here's my 1, 0. Let's say 14 is maybe here. We're going to have a maximum at 14. So from here, like this, and then back down to our 22.2, okay? So if we want to answer the question, we can say, therefore, the maximum profit, which we can see our maximum profit at 14,000 tins, or the maximum profit of $202,160 occurs when 14,000 tins are sold. Okay, so some calculations and kind of thinking through that to figure out what our maximum is. But we were able to factor, find our zeros, and then do some test points to figure where is that maximum occurring. Remember, the domain represents all of our x values. So if we look at our x values, we should think about the fact that this is a real world application problem, and that we're talking about the number of tins sold and our profit. So we can't have negative for either of those. So when we're looking at our number of tins sold, which would represent our x values, which is what our domain is, right? We can't have negative tins sold. We're looking at our function though. It looks like the number of tins sold can be anywhere from 0 all the way to 22.2, right? Because anything past 22.2 is going to have negative profit. So we're not going to sell tins past 22.2, which would be 22,002. So finally, what is the domain of the function? Positive 1 sold. So just remember that domain, those are your x values. So we would say that our domain, when we write it like this, is going to be n is greater than or equal to 0, n is less than or equal to 22,200. Where n is all real numbers. Okay, and it says explain, so can't sell negative numbers of tins. All right, let's look at a few more examples. So the stopping distance, d in meters, of a car traveling at v kilometers per hour is given by the formula that you see there. So d equals 0.0066 v squared plus 0.14 v. So find the speed at which a car can be stopped in 35 meters. So it says find the speed, all right, and it says up here that a car traveling at v kilometers per hour. So we're trying to find v, at which a car can be stopped in 35 meters. That 35 meters is going to represent our distance. So we're going to find v when d equals 35. So go ahead and pause the video and see if you can work through this problem to figure out at what speed that will happen. Okay, so here is the values we should get for our x values when we sub in d for 35. So when we substitute the 35 in for d, we're going to bring it over to the other side of the equation once we do, so that the equation is equal to 0. So we're going to set equal to 0 by minusing 35, right? We're going to move that 35 over by subtracting it so that the equation is set equal to 0. And then once we do, we're going to plug into our quadratic formula. You'll see when we solve using our quadratic formula, we end up with 63 or a negative 84.2. So remember what we're trying to find here. We're trying to find the speed. So we can't have a negative 84.2. So we would just say that this is not possible. So now we only have one possible solution. We can answer the question. So remember, the question was find the speed at which a car can be stopped in 35 meters. So we could say, therefore, a car can be stopped in 35 meters when traveling, we'll say 63 kilometers per hour. Okay, one more problem for today. So the hypotenuse of a right triangle is 29 centimeters. If the other two sides differ by 1 centimeter, what are their lengths? So let's think about this for a minute. So let's draw a right triangle and try to think about what we know about a right triangle. We have a right triangle. What my right angle there? It says the hypotenuse is 29 centimeters. So remember, the hypotenuse is always that side across from that right angle. It says if the other two sides differ by 1 centimeter, what are their lengths? So we need to establish what does that really mean. We're going to give a variable to this. So let's let one side be x. So let's let x be the base of the triangle. So if I say the base of the triangle is x, well, it says the two sides differ by 1 centimeter. So if the base is x, we could say that the height is going to be x plus 1, right? Then the difference between those will just be 1 centimeter. So we have a nicely labeled diagram. We have to think about what do we know about right triangles in order to help us solve this. So hopefully you can remember that we do have an equation for a right triangle when we're trying to find a side. It looks something like this. A squared plus b squared equals c squared. And recall, this is our Pythagorean theorem. So I'm going to substitute into this. Remember that c represents our hypotenuse. So I'm going to let a squared be my x. I'm going to let b squared be that x plus 1. And we'll let c squared be 29. Okay, so we will work to simplify this and then figure out what are our possible x values. Okay, so x squared is just x squared. But x plus 1, we're going to write as x plus 1 times x plus 1. Because remember, that squared terms means we're multiplying the bracket by itself twice. And then 29 squared equals 841. So let's keep expanding this. I'm going to expand my binomials here by using FOIL. So x times x squared is x squared plus 1x plus 1x plus 1 equals 841. So I'm going to start combining my like terms. So x squared plus x squared is 2x squared. And I have x plus x, that's 2x plus 1. And I'm going to bring over that 841 as well, so I can get my equation set equal to 0. So I'm going to subtract 841, which will equal 0. So 2x squared plus 2x minus 840 equals 0. So we need to work to get this into factored form now so that we can find what those x values equal, right, to find the solution. So factor. So I'm gonna common factor out 2 to begin with. I can see that there's 2 in common here with all my terms. So I'm going to take out a 2, and you're going to have x squared plus x. Okay, and then we'll minus. So 840 divided by 2 is going to be 420. Okay, now I'll continue factoring this. See, I have a simple trinomial now inside my brackets, so I'm going to set up SPF. So I need 2 numbers that are going to add to a positive 1, but multiply to a negative 420. So I have to think about the factors of 420, and you should get to a positive 21 and negative 20. Okay, so positive 21 times negative 20 is a negative 420, and if we were to add those 2 numbers together, they would equal a positive 1. So we would have x plus 21, x minus 20 equals 0. So then when we're pulling those out to find our zeros, for this one we'd have x equals a negative 21, and for x minus 20 we'd have x equals 20. Well, remember, we're talking about the side lengths of a triangle, so this one is not possible. Right, we can't have a negative 20. So we have this 20 to work with. So we could say 20 would be one of the sides. I'm just going to finish it up over here. So we have x equals 20. So then x plus 1 is going to equal 21. So therefore we can say the other 2 sides are 20 centimeters and 21 centimeters. There you go. That's the note for today.